What I thought we should look at before I jump into the new material and jump into it. Okay, Jacob, go for it.
Problem number 1.
Okay.
Find the exact value of the given expression.
Okay, hang on. Okay,
Sine, or inverse sine,
hang on just a second. Okay, inverse sine.
of negative radical 2/2.
Now that, if you see on the exam coming up on Wednesday, I think the exam does cover the inverses. Is that true?
Mhm.
Okay. Guys, this one's just sort of straightforward. Translated says you're looking for an angle whose sine is what it means. Sine of theta is equal to this. Put a comma, but since it's an inverse where we chopped off pieces of sine graph, there was a constraint. The answer for theta must fall between what?
0 and 2 pi.
Over
sorry.
to
There, that's my bad.
You gotta know this. Now, does anyone have, and by the way, I started you out with one that you should recognize from the unit circle. Does anyone recognize radical 2/2 and something that was related to it from the unit circle?
Negative pi over 4.
Looks like it's pi over 4 somehow involved. Now, if I say pi over 4 is in quadrant 1, I've got to know, where is it negative?
Quadrant 4.
Quadrant 4, now be careful. So how are you going to rename that pi over 4 to get it down to quadrant 4 where sine is negative? How are you going to rename that?
Negative pi.
Negative pi over 4.
And negative pi over 4 would do it. Done. So be very careful on the location here. Okay, Jacob, what's the second one?
Secant
Okay.
of inverse tangent of negative 2/3.
Now, this is nice. Jacob, you say something like this?
Mhm.
Okay. Guys, translation, you gotta be ready for this. This inside here tells me there's an angle out there, and when you find its tangent, you get this. That's my translation. And since I'm doing an inverse, what did we accept for the constraint placed on theta? It should be located where?
In quadrant 1,
Or quadrant?
3. Or wait, no, sorry. Oh, sorry. Quadrant 4.
Yeah, it was written like this, I think.
Sorry, I'm getting my things mixed up.
Is that true, guys?
Yep.
It's got to be located between negative pi over 2 and positive pi over 2. You sort of have to, I hate to use the word memorize. You gotta know these. So I know where the angle is supposed to be located. And by the way, Jacob, I heard what you said. If you think about this, guys, this means you're either in quadrant 1 or quadrant what? 4. And since tangent is negative 2/3, which of those two quadrants is tan negative to begin with? Quadrant 1 or quadrant 4? Quadrant 4. So my sketch to show this must be in quadrant 4. That's what I thought to these. So the angle's down here in quadrant 4. They want the secant of that angle. And I have no idea what size that angle is. I have no idea myself. It's not one of those from the unit circle. It's not 45 or 60 or 30. It's not one of those. God knows what it is. But they're asking for a secant. Any ideas?
You try and
Use
rewrite.
the identity.
tangent.
Thank you.
Yeah.
There's a nice identity that relates these two. What was it? 1 plus tan squared absolutely is equal to what? Secant squared?
Square.
If I use it in the raw form that you see right there as the identity, I know tan is negative 2/3, so I could replace that. Do this. You guys, looks like it's gonna be 1 plus, what is that, 4/9?
Mhm.
Marker's not good. 1 plus 4/9. I'm running out of board space here. What is that, 13/9? the number. Do a square root, that's square root 13 over what, 3?
Yeah.
And this is for secant. By the way, I'm in quadrant 4, we determined, and secant should be positive, and it is positive in quadrant 4, so everything's good right now. Strange number, square root 13 over 3. Is that what they wanted? Is that what they asked me to find?
Yes.
If it is, we're finished.
Yep.
You see, Jim, we're gonna check this in a few seconds. But, here's an alternative. You say, Professor, if you leave it open, and you do not insist on us using an identity and show the identity, it's an alternative. Well, you could do this. You could draw a perpendicular, always to the x-axis, and form a small right triangle. What do I know about this triangle? Tangent is negative 2/3. Does anyone have any idea how to label any of those sides of that right triangle down there? This is alternative number 2.
Well,
Alternative number
first
1.
off, don't we know the hypotenuse has to be?
Well, the black piece, if it's a unit circle, it's gonna be what, 1?
Yeah.
I can mark that. And to get tangent to be a negative 2/3, guys, please tell me y over x. Can I put negative 2 here and 3 here?
3, yeah.
Is that true? Now though, that's gonna change this. C squared is equal to A squared plus B squared. Can anyone tell me right quickly, if you use Pythagorean theorem, what would that give me? I want a 1, of course, but it's not gonna be a 1 with the way we labeled. This is gonna be what?
9 squared, wait, it would be root 13.
Root 13.
Yeah.
That true, guys? C squared is equal to A squared plus B squared. Now, Nathan, I can go back to what we're accustomed to. We're accustomed to that being a 1. I think I showed you guys one of those last week. I can easily do this, change it back to a 1, which is easier to work with. Make this a unit circle. Just divide this by, all of them by this. Now, back to the unit circle. This is 1 now. And now I'm asking for, what was it they're asking for? Secant. Secant should be 1 over x. And by the way, guys, my x right now looks like that. Is that true? So it's 1 over,
3 over.
yeah, look at that mess.
Radical 13,
3 over radical 13.
or we just flip.
Just a reciprocal, right?
Yeah.
If I do a reciprocal here, guys, I'm gonna end up what? Radical 13 over 3? I think. And that's the same thing we end up with over there. Yes or no? Is that true?
Yeah.
Many students like this. They say, Professor, let me drop a perpendicular, I feel more comfortable with the right triangle. If I say no, or I may just leave it open, if you use an identity, then you have to go through this business. And some, I may do a mix. You could do a couple of these by this approach with the identity, and maybe leave it open for the others. How's that look? Okay, Suji. My dear, do me a favor. We know secant is this strange, or tangent. Fine, just tangent of 2/3, do it in degrees. Tangent of 2/3.
Tangent of 2/3 is 0.0116.
Okay, now do it in degrees. Give me a-
It's in degrees.
Oh, that's degrees?
Mm-hmm.
Just, oh, okay, got you, do inverse tan, just 2/3.
Inverse would be 33.69.
Now, that's this little angle down here, if I were actually using a calculator. So this little angle right here in the corner we were talking about earlier is a measure of 33.69 degrees. They wanted, I guess, secant of that. Susie, do cosine of this and then do a reciprocal turned into secant. Do cosine first of this.
Cosine of
Of 33.69. I know that takes a little time, but it's crazy.
So cosine of that is 0.8832.
832. Now do a reciprocal of 0.832. We'll turn it into a secant.
1.2.
1.2?
Mhm.
Oh my goodness. We got this. Now see what square root 13 divided by 3 is.
Square root of 13 divided by 3. 1.2.
Yes, good checks. Now I see some looks. I know that's looks because I haven't seen you since Wednesday. Oh, Professor, that's just your first recap that you're working on. We're not into the new material yet. Jacob, was there something else to be done there?
Yes, there was.
Okay, what was that?
Inverse cosine
Hang on now. Inverse cosine.
of cosine of 10 pi over 9.
Oh, oh, oh. Oh. The 4 o'clock session. We recognize, and I think every student will recognize, wait, Professor, this reminds me so much of something we had done in class using that property. Is that true, guys? Yeah. So I would think, my goodness, the answer is 10 pi over 9. Is that true? The way the property works? But we have a constraint placed on us. By inverse cosine, the constraint was, help me out here, guys, 0 to pi, was it? Yes or no?
Yeah.
Yes.
So if this right here does not fall where it should fall by constraint, I can't use it. Now let me find where 10 pi over 9 is located. Okay, guys, this is 9 pi over 9 here for reference if you wish. So would 10 pi over 9 take me down to quadrant 3?
Mhm.
Come down here. The constraint says you should be either in quadrant 1 or quadrant 2 from 0 to pi. The angle should be from 0 to pi. That's quadrant 1, quadrant 2. I'm in the wrong quadrant. Now, can someone help me move it to where it should be? Jacob, go for it.
Well, wouldn't there be a reference?
That's a reference angle.
In quadrant 2.
Now let me do the green here. This represents 10 pi over what, 9?
Yeah.
So that little reference angle in the corner there, which is going to help, was what, the difference?
Yeah, it would be.
That'd be what, pi over 9? We squeeze that in right here. Nice problem. So guys, I'm in the wrong quadrant. I've got to get into the correct quadrant, and the correct quadrant is either quadrant 1 or quadrant 2 by constraint here. I'm down in quadrant 3 right now, and I'm doing a cosine. What is cosine, positive or negative if you're in quadrant 3?
Negative.
Negative. You've got to retain that. So of those two quadrants where I should be, 1 or 2, which one retains the negative?
Quadrant 2.
Yeah, so my angle must be up here with this little reference angle to follow there. I moved it to quadrant 2. Am I in the right quadrant now?
Mhm.
Now, what size angle is that? Be careful.
8.
There you go. The angle itself is this angle. Do you guys agree? I think that is what, 8 pi over 9? Are you kidding? There is an answer. It's not this. We tried. It's this. Hey, Suji, do me a favor. Ooh, do it in degrees. Put this in inverse cosine of, and we'll change that to degrees right quickly, 9 and 120. I think it's 200 degrees. Inverse cosine 200 degrees.
It's 160.
And this right here is 160. As we convert this to degrees, is that 160?
Yes.
So it works out. Now that is when you see 1, I'll just place 1 like this on the exam. 1's enough. This is going to be a challenge. 1 like this will be a challenge. Just make sure you place it in the correct quadrant and then name it. I'm gonna see a hand going up. Yes?
Can you use this technique with other things like secant
All of
of
them.
inverse tangent?
Yes. Now, when you say this method, the method, we gotta make sure it's inverse cosine with a cosine.
That's right.
Inverse sine with a sine.
Right.
Inverse tan with a tan. Not this other business.
And would it work also with cosine of inverse cosine?
Yes.
Okay.
Oh, you wanna put cosine out front,
Yeah.
and then inverse inside, absolutely. Good thinking, absolutely. Jacob, please tell me, was that the last of the recap?
Yes.
Okay, now hang on. Yeah, Deborah,
Oh, wait, no.
hang on.
I'm just wondering why you're moving it to quadrant 2 when the cosine is positive, like in the original equation.
Cosine, the original, angle is down in quadrant, 3,
Uh-huh.
and cosine down in quadrant 3 is negative.
It is.
And I had
But then
to,
when you move cosine to quadrant 2, cosine is still negative in quadrant 2, sine is positive there.
I'm not concerned about a sine.
You just want the cosine to be.
We just want cosine. There's no sine involved, you just wanna make sure cosine.
That's why I'm wondering why it's there, because that's where sine is positive, not where cosine.
Yeah, and I'm not concerned at all about sine, tangent, cosecant, all I'm concerned about is cosine. This is something like Jacob asked. He says, Professor, will this method work only if these match up? Cosine with cosine, sine with sine, tan with tan.
But isn't cosine supposed to be positive?
What's it now?
Isn't cosine supposed to be positive, and isn't it negative there?
Well, the angle's down here, 10 pi over 9 is down in quadrant 3.
Oh, okay.
I sketched the angle. 10 pi over 9 is down in quadrant 3. Please tell me, is cosine negative down in quadrant 3?
Yes.
Well, of course it is. So it's negative down here. I see what you guys are looking at though. This is quadrant 3. It's negative. Deborah? It will drive you nuts. It'll drive you, and I'm gonna send out the solutions to this, on Tuesday, tomorrow, so you will see the solution again. Would it help if I threw in another one, just for practice?
Yeah.
Okay, on that, okay.
Another one.
Yeah, one of these crazy ones. Okay. Okay, Jacob, is that recap finished?
We have a part two to it, so we have,
What's part 2?
solve the given trigonometric equation.
Yes.
On the binding of 0 to 2 pi.
Hang on.
Including 0.
Now, you know this is the last part of your exam, solving equations. Yeah, get a good marker here. Okay, read it for me.
1 plus sine theta equals 2 cosine squared of theta.
And I said solve this on, I think, from 0 up to what, 2 pi?
Yeah, but not including 2 pi.
There you go. The textbook does the same thing. Now, guys, if you see one like that, that's fortunate. Why? Matthew, get me started.
We can start by replacing the one with sine squared plus cosine squared.
So you're telling me right here, Matthew, I can quickly rewrite cosine squared using sine squared plus cosine squared is equal to 1. What can I rewrite that as?
1 minus sine squared.
Beautiful.
Or, well, this is-
Yeah, some mathematicians in here. Got 2 here. And of course, you still got this. Now, everything's in terms of sine. And since I see that square there, this will be a quadratic. And guys, if I clean this thing up, 1 plus sine theta, looks like it's going to be 2, subtract 2 sine squared theta. Let me make a mistake. Oh, it is going to be a quadratic. Let's move everything over, guys, to the left. It's up to you. Place this in order. And looks like it might be, let me step back, make sure. It may look like that. You guys agree? That's the way it looks? I just move, that's algebra, which move things over to one side, the left. Yes or no?
Yes.
Now, what do you think you as a student may do now? Nathan?
Let u
Yes.
equal sine.
Thank you. You end up with 2u squared plus u, subtract 1 is equal to 0. That will factor from algebra. I think it's what, 2u, and the plus 1 goes here, minus 1 goes there. Okay, guys, if I split this up and solve it, you know the routine, you will end up with this. and that. And he told me to let you represent sine theta, so this is sine theta equals 1/2. Sine theta is equal to a -1. Now, you've looked out on these. I must make sure that the end result is something you recognize from the unit circle on these. Guys, you should recognize on the unit circle where sine y is 1/2. Name a spot where that happens.
5 or 6.
5 or 6 is one of them, and I think there's another.
5 or 6.
5 or 6, gotta know your business here. Those are the only two if you check the unit circles. Make sure you know that unit circle. Here, I think there's one on the unit circle where this is true.
3 pi over 10.
3 pi over 2. And that's the only one. And therefore, those three are the solution to this. And close that out. You guys agree? That one's not that bad, was it? No. You have to know your identities. Was that the last of it?
Yes,
Oh, that's the last.
that's the last recap.
Whoa. Okay. You have to remind me, Jacob, before we leave tonight, I just thought of something else I should have placed on that recap. Would be to graph something with a cosecant in it. Right, like we were doing in that 4 o'clock session? Something with a cosecant or a secant, just for a little reference there. I'll do that, don't let me leave. I'll create one right quickly. Now, what is the next part all about?
Sum and difference.
Oh my gosh, you're gonna love these. You're gonna love these. Let's call this part 3, I guess. And he says, Professor, it's all about this. Sum, difference, formulas. And there's one thing we all like, me included. Give me a formula. If you give the formula to me, Professor, I can plug in what's needed, and I'll give you an answer. Now though, before he jumps in and starts naming those formulas for me, please tell me what you think if you saw this, and this one's a sum of 2 angles, I'm doing a cosine function, on a sum of A and B, A plus B. I would, if I had no experience in trig, I may think cosine A plus B, Professor, no problem, you should use the distributive property, distribute cosine, and it should be this. So what's the issue? The issue is will not work. Now let's see why it may not work. Let me see if I can come up with a nice pair of angles that you would recognize from the unit circle to show that this may not work. Guys, let's try on this one. Let's try cosine of, now hang on just a second. Let's see if we can do it, or if I can do it. Okay. Why not? Let's take pi over 6, 30 degrees, and add to it pi over 3, which is 60 degrees. Let's consider those two for A and B. In other words, pi over 6, 30 degrees, plus pi over 3, 60 degrees. And I know, and you know, that's cosine of, put those two together in the common denominator, reduce it down. I think it's cosine pi over 2, is it? Is that true? If we add these up, with the common denominator of 6, reduce it. And I know from the unit circle, Nathan, the cosine, the x coordinate at pi over 2 is, don't scare me.
0. Yeah.
Who said that? Someone scared me. It's a 0. Now suppose I'm naive. And I say, wait now, this should work, Professor. Why don't you do it this way? Okay, let me go back up to the red here. Okay, let's take cosine pi over 6 plus cosine pi over 3. I think you see way ahead, it's not gonna work. Cosine of 30 degrees or 5 or 6, what was that, guys? Radical 3/2, I think. And cosine of 60 degrees or pi over 3 was what, 1/2? Did I have the right numbers? Yes or no?
Yes.
So you would have something like this for an answer for this. When the answer should have been what? 0. I wish it were that easy. I wish you could just use a distributive property and go right through it and get the answer. Can't do it. Jacob, I can't remember what order I placed all these formulas. Could you find the formula for cosine A plus B, the one we have to follow? This one's not working. And tell me.
Cosine A plus B equals.
Okay, hang on. Cosine A plus B equals,
Cosine A, cosine B,
hang on. Okay.
minus sine A, sine B.
Oh my goodness. You're tempted to say this is cosine squared. Why can't I not call it cosine squared?
Because there's an A.
There's an A and a B, different angles. I can't do that, so I gotta leave it in that raw form. Now let me try this on my original problem, where I asked you to find cosine of pi over 6 plus pi over 3. And with the formula he just gave me, this is cosine pi over 6, cosine pi over 3, subtract sine pi over 6, sine pi over 3. We'll try it. Guys, from the unit circle, cosine of 30 degrees, cosine, what, pi over 6 is how much? Remind me. Is that radical 3/2?
Yep.
And cosine this one, I think was what, 1/2? And then down here, sine of 30, who remembers sine of 30 or sine of 5 or 6? 1/2.
Radical 3/2.
Radical 3/2. And how cute. This is radical 3/4. Subtract radical 3/4. There's the 0 that we wanted. Now, Fatima, if your professor would show you the derivation where this came from, there's a geometric interpretation. I have to make a grid, draw some triangles, a triangle with an angle A in it, a triangle with angle B. I could do it and show you geometrically that makes sense. That strange formula there with some triangles, but I don't have the time because it may take 10, 15 minutes here. Guys, can we deal with this? Gotta know your formulas. Now, if I know that one, Jacob, tell me please, is there one on there for cosine A subtract B? Not A plus B. And what does that say?
Cosine A subtract B equals cosine A, cosine B plus
Uh-oh.
sine A, sine B.
Now, please tell me. Nacio, if you know this one, down here, surely to goodness, would you know this one? So if you actually memorize, I hate to use that word, if you memorize the first one, can you just easily then say, Professor, if I know this one, down here, that he gave you, is there a way to know this one? This one just says what, the difference between A and B. Yeah, if it's a minus sign here, it turns into a plus. I think on mine over here, it's what, a plus inside, turned to a minus. That's all that's going on. Laura, I'm gonna accept this formula. I'm not showing you a derivation where it came from at all, I'm gonna accept the formula. But, Laura, I would like to try to find cosine of, let me stand here and try to come up with a nice one here. Yeah. Pi over 12. See if that'll work for me. I hope it works for me. Can someone tell me in degrees right quickly, what is pi over 12? What size angle is that? In degrees? 15 degrees.
Gotcha.
You'll say, Professor, I've never seen a 15-degree angle, and I don't want to see a 15-degree angle, ever. It's not on the unit circle, Professor. Then you gotta be clever on the, when you see this on the final exam. You gotta be clever and say, wait now, can I express 15 degrees as two angles with a difference between them to form 15 degrees? Like what?
Like 60 or.
60 subtract 45?
45, yeah.
Or 45 subtract 30. Either one will easily give it to you. So if I rewrite this as cosine, guys, I think I'm gonna use pi over 4, subtract pi over 6, 45 subtract 30, and then use this formula. If I use this formula, Laura, here goes. We will have cosine pi over 4, 45 degrees, cosine pi over 6, and that's a plus sign, sine pi over 4, sine pi over 6. Is that true? And if I'm very, 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 very careful, cosine of pi over 4, we all know is radical 2 over 2. I know that unit circle. Cosine of pi over 6, I think it's radical 3 over 2. Sine of 45, another radical 2 over 2. And of course, this one's 1/2. Guys, to do it fairly quickly, you're going to end up with radical 6 plus radical 2 all over 4. Now what is this? That's the cosine of pi over 12. Radical 6 plus radical 2 all over 4. Whoa. See how helpful that was? Okay, no calculator needed. Now, you see, do me another favor. You're busy tonight. Find just straightforward cosine of 15 degrees.
0.966.
Let's just call it 9.6,
Yes, 0.97.
9.7. Okay. We have this. Now be very careful. Find radical 6 plus radical 2. You may want to enter, get that much out of the way, and divide by 4. See what this is.
9.97. 0.97.
Gotcha. Same answer. So those formulas are helpful, aren't they? Now, Ignacio, I can't go crazy on you and give you, this is what, 15 degrees? If I made a mistake when I construct the final exams and give you not 15 degrees, I made a mistake, I wasn't careful, and I gave you 18 degrees. And you're taking the test. You say, wait, Professor, I gotta find two angles whose difference is 18 degrees. We got some angles out there whose difference is 18 degrees. What, like 20 subtract 2? A 20-degree angle and a 2-degree angle? But are those two located on that unit circle for us? No, so I'm gonna be very careful and find, or make sure it's appropriate for the unit circle. This one was. Jacob, what else do we have?
Other than that, we have 2 more formulas.
There's 2 more.
Yes.
Okay, hang on. By the way, guys, does this help to have that in front of you on a handout?
Yes.
Yes.
I think it does. Okay, next one I guess is a sine, maybe?
Sine,
Okay, hang on.
oh,
Okay, sine of what?
sine of A plus B
Got you?
equals sine A cosine B plus cosine A sine B.
Jeez. Thank goodness you have only 4 of these. This is the next one here. Sine A plus B. Laura, I used your name last time. Now let's try to find sine of, if I accept this formula, I did not derive it for you, I didn't show you where it came from. Let's try maybe 5 pi over 12. Guys, someone help me out. How many degrees is that right quickly? What's 5 pi over 12 if you convert it to degrees?
75.
75. And I'd like to find sine of that. Now, are there two angles on the unit circle whose sum is 75 degrees?
Yeah.
45 and
30.
30. So why not rewrite this as? Is that true? And then apply the formula. If I apply the formula, and she's going to check it here for us shortly. This is sine pi over 4, cosine pi over 6. He's giving me a plus sign there. Cosine pi over 4, sine pi over 6. Let me step back and look at it, make sure everything's placed. It is, thank goodness we're on the unit circle. This is radical 2 over 2. You know this is radical 3 over 2. This is a radical 2 over 2. And we know this is a 1/2. Yes, no, guys? That true? Looks like we end up with radical 6 plus radical 2. Nathan, looks like all of our common denominator 4. What would you agree?
Hmm?
And that's sine of 75 degrees, 5 pi over 12. Yes or no? Now, I see Ignacio looking at something. Other students should be looking. We did the correct procedure. Ignacio, what are you looking at? I saw you looking. No, you're glanced over here for some reason. Did we not have that same answer over there?
Yeah.
That was a different problem. Here, ask you to find what? Cosine of what, 15 degrees?
Yeah.
We got this, and we used a formula. And all of a sudden, I turned into sine of 75 degrees, and if I used the formula correctly that Jacob gave me, we got the same answers over there. Hold on. What on earth is going on? Why are they the same? Oh, it could be a reference angle, maybe. Yeah, could be a reference angle involved. You'll be shocked. What's going on here? Which I've held off on and didn't tell you until tonight. Matthew, what do you think it is?
I don't have the right way of explaining it, I think, but it doesn't, to a certain extent, it almost doesn't matter what the angle is, but if you perform the function on the formula on it, you will end up with this answer.
If I use the formula,
Yeah.
okay? Okay, we've used the formula on both of these now, but my question is, does anyone think they know? And you're gonna be shocked. Why? Because if I were taking a test, an exam, and I did this perfectly, and I felt so good, and I got this, then all of a sudden Ramsey has the next question be this. Where was it? Over here. Next question is this, and all of a sudden I get the same answer, then I'm gonna slow down and say, I've done something wrong. Part A, I got that. Then part B, I got that. Oh, I must have made a mistake. And all of a sudden, you don't have a mistake. They are the same answer. But it's a different question. This is sine 75. This was a cosine 15. Someone's got to tell me, why are they the same? You're going to be shocked. You're going to be shocked. As nothing really mathematically. Something else. Go for it.
Is it because cosine, which is like related to the x-axis, it's the same distance away as sine is, which is related to the y-axis?
It could.
30 and 60.
Well, yeah, exactly, that's what he's sort of thinking of. Something easier than that, which I held off until tonight. And really, there's no mathematics required, like you guys are talking about 30, 60, Sophia, in your mind, which is good, Something easier than that. Why would those be the same answer?
Could you
Now let me point out right quickly. Look at this. The word cosine.
oh, it's
The word cosine has sine in it. Is that true? Now, can anyone tell me, take a good look, what on earth is the CO? I know it has something to do with sine, because sine's in cosine. Wonder what the CO is. So someone's about to give me a vocabulary word from a previous course, probably back in middle school, that you used back then that started with a CO.
Constant.
Not constant, yeah, constant does start with CO, but it's not constant. Cotan? No? I get this every semester. Coefficient, not coefficient. Something I know you did back in middle school, maybe earlier. That's going on here. I'll give you a little hint. Whoa, hang on.
Oh, yeah.
Tell me again.
Complementary?
Now, if she says complementary, that starts with a CO. Lillian. Lillian says, wait, Professor, I think CO represents this. I think I spelled that right.
Yeah, that's about class.
That's CO.
That's cold, that's
Complementary.
No one here can spell, we're at math for a reason.
Let's say complement. Now, complementary.
Yeah,
What about complementary angles?
they add up to 90.
They add up to 90. Nathan, do my two angles. 15 and 75 add up to 90.
They sure do.
Every time they do, then sine of this one's gonna be equal to cosine of this one. Now, hold on. So without a calculator, if Austin, if you see this on the test, and I say, go ahead and find it, and you say, Professor, when you constructed the final exam, you made a mistake. Oh, you have to find this. I know it's equivalent to, right quickly, I come up with a value, it's equivalent to what? Cosine of 80. They must add up to, as Lillian said, complementary. Deborah, if they do not add up to 90, you can't do this. You're not gonna get the same response. Does that make sense? That's why I held off on those vocabulary words, the definitions for the 6 trig functions, and you guys accepted it was cosine. I just went on, I didn't say what the CO meant, what the sine meant. This is what it means, the sine of the complement. And that will work. That's why these two worked out. Okay, so CO means complement in terms of what we're doing here. Jacob, I thought you had a question there.
Does that also relate to like cotangent and
Beautiful,
cosecant?
beautiful. Look at this. Let me go ahead and do it right here. Cotangent. Cotangent here. Should be equivalent to tangent. Now, hang on now. It's tangent. Write a little bit better here. Cotangent theta. Anyone in this brilliant class that other professors are so amazed with, can someone tell me a nice way to express, if I just say theta, and I don't give you a specific number here, what would you say they should be equivalent to? Cotangent theta is the same as tan of its complement. How would you express theta's complement?
1/2 minus theta.
Thank you, 90 subtract theta. 5/2, Lisa, thank you. That's a true statement. By the way, the one I just did here, I think I did a cosine here, maybe, yeah. Cosine, Jacob, is the same as sine of the complement. Now, what other CO could I use?
Cosecant.
Cosecant? Should be equal to what? Secant
Secant.
of the complement.
Pi over 2 minus theta.
Whoa! There's another relationship, as if you didn't have enough to worry about. This was that CO word. Okay, I thought I would point that out. The reason I did that on the handout for you guys, I made sure I did it on purpose. This answer came out to be this, and I did see some students' eyes look over here. They said, "What, Professor, I think you made a mistake, because you got this over here, and all of a sudden you got it again." There's a different problem. That's all due to this. You guys okay with the complements, complementaries? Now, do we have, here we go. Jacob, do we have one more
Yes, we do.
Okay, hang on. Letter D, I guess. Name the last one.
Sine
Okay,
A minus B equals sine A cosine B.
hang on, sine A, cosine B,
Minus cosine A sine B.
cosine
Just
A,
look at this,
sine B.
the, sign in front of it.
There you go. So if you know one, sure to goodness, if you know this one, you'll know this one. So they're easily memorized. Okay, guys, and you could apply this also on the unit circle. Yes?
Does it matter if we met, like, say we're doing this and we accidentally put cosine A sine B in front of sine A cosine B, it'll all come out to be the same thing?
What are you talking about? You talking about, we'll move this over?
Yeah, if we if we accidentally flip the two that are on the right side of the equation.
Oh, here.
Yeah,
Yeah,
if we,
flip, you mean you would write this first, this, and then this?
yeah,
Just backwards? Ah, you got the same answer there.
okay.
I don't think we'll try it here.
Mhm.
No, don't try it here with that minus sign. Over there would be okay. Okay.
Thank you.
Now, do I have some now problems to work out with this?
Sure do.
Okay, here we go. Guys? We'll call this, I guess, part 4 already. Try to get this chapter 6 finished. Jacob, what is next?
Sine 7 pi over 12.
Hang on. You see that on the exam? You say, oh, no, I'll see you during the winter session, Professor. I've never seen 7, 5, or 12, not on the unit circle. Now, can anyone come up with two angles that you have seen whose sum is 7, 5, or 12, or whose difference is 7, 5, or 12? And if so, I'll try to use those. Matthew?
Sine pi over 4 plus pi over 3.
Pi over 4 plus pi over 3? Hang on. And I'm looking at those right quickly with the common denominator of 12. I see 3 plus 4. Beautiful. Now I can get the answer by the sine A plus B over there formula with what he gave me. Sine pi over 4 cosine pi over 3 plus cosine pi over 4 sine pi over 3. Gotta know your formulas. I think I had that copied down correctly. Okay, Matthew, this is a radical 2 over 2.
Radical 2 over 2 times 1/2.
Okay, this is 1/2 here.
Yeah, plus root 3 over 2.
Radical
times-
2 over 2. I have mine in this order.
Oh, root, yeah, root.
You may have turned around. And then down here was what?
Root 3 over 2.
Radical 3 over 2.
And then that feeds us to, if you do all the math, root 6 plus root 2 over 4.
Thank you. What's that? If we have no mistake.
Right-hand, it's the same.
You guys agree?
This-
Jacob, what was that?
Isn't it the same again?
Uh-oh. This one, did we get this? We've got sine of 5 pi over 12. Now, this one's not a cosine, so you can't use that co-function business. It's not cosine, is it?
Mhm.
So I can't use because I don't have a CO. Sine of 7 pi over 12. Okay, here we go. Jacob? Wow, here we go. Let me locate 5 pi over 12. Where's 5 pi over 12 located?
It would be 1/12 away from,
Is it quadrant 1, quadrant 2,
Oh,
quadrant 3,
quadrant
quadrant 4?
one,
Just quadrant, which quadrant?
sorry,
I'm
quadrant.
here in quadrant 1.
Yep.
I say this is 5 pi over 12. By the time you get here, that's what, 6 pi over 12.
Yeah.
And the other, for a comparison, is 7 pi over 12. Is that over here?
Mhm.
Correct.
The two guys?
Yeah.
So I'm comparing this angle, I guess, to this one. Now, could I argue just by sketch that when I take the sine, the y coordinate, of 5 pi over 12 quadrant 1 should match up with sine of 7 pi over 12 in quadrant 2? Is sine, or at least are they both positive?
Yeah.
And could I argue with that reference angle that they should be the same? So I can just show a little graph on the side there and argue that. Yes, they are the same. But it's not because of co-functions. There's no CO in this one. It just happened to work out like that. Okay, Jacob, what's next?
We have cosine of 5 pi over 12,
Hang on now. Cosine of 5 pi over 12.
cosine of 7 pi over 12,
Hold on now. And cosine of 7 pi?
over 12,
Okay.
minus
Hang on. Minus?
sine
Okay.
of 5 pi over 12,
Beautiful.
and sine of 7 pi over 12.
Now. And you've never had the experience of 5 pi over 12 or 7 pi over 12 on the unit circle. It's not there. What's going on?
It's 12.
What's going on? Does this mess, does it match up with, let's see if I can find the right one here. Does it match up with this one right here?
No.
No.
Does it match up with cosine, cosine? Does it match up with this one?
No.
Okay, does it match up?
Plus B. Yeah,
Which one?
it's cosine A plus B.
Was it down here?
Yeah.
So all that's equivalent to what? Cosine A plus B. So in this case, where are we here? You guys can find, what was it?
Your left.
On the left of here, right here. So this is cosine of 5 pi over 12, plus, was it?
Yeah, 7
Should be
pi
at 12,
over
7 pi over 12. And that's cosine, I guess, what, pi? Yes or no?
Yeah.
If it is, there's the answer.
-1.
Relationships, relationships. That true? Okay, Jacob, what else?
We have cosine
Hang on. I'm all over the board here. That's B, this is C, I guess. Okay, cosine.
of inverse tangent.
Whoa, 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 whoa.
4 over 3
Oh, no.
minus
Okay.
inverse cosine
Are you kidding? Okay.
of 5 over 13.
Mm. I'm almost so tempted to say if someone can get this one in 5 minutes, the answer with a valid solution, maybe I could exempt you from the test. Look how crazy that looks. And then what you're probably thinking is, Professor, we're back to inverses? I thought we were finished with the inverses. Oh, they brought them right back into some of these formulas. How to get a start here, guys? Someone give me a start.
Well, why don't we try and find out what the inverse of
Now, you know inverse tan of 4/3, you will not be able to find that on the unit circle. You will not be able to find this one on the unit circle. Not 5/13 is not on the unit circle. So I need some help. How are you going to start?
maybe a trick, I think.
Now something else is staring at you, you're overlooking it.
Yeah,
And it
start-
connects with this lesson.
Rewrite it using the cosine of A minus.
Thank you. This is cosine A subtract B.
Yeah.
Now watch carefully, because I have one of these on the test. On the final exam. I'm talking about final exam. Don't get too excited. Here we go. Now, this means tan A, we're calling it, is equal to 4/3. That's what it means. And since I see an inverse, A should be located by restriction where? Between
Pi over 2
and
pi over
5/2, and you guys are like quadrants.
quadrant
Quadrant 1,
quadrant
quadrant
4.
4. Okay, now I'll come back to it. Now inverse cosine that we did, we discussed inverse cosine earlier. This means,
Cosine of B equals 5 over
Fluid.
13, and it has to be in quadrants 1 and 2.
Or tell me the constraints first and I'll place the quadrants. I think 0 to pi.
0 to pi and quadrant 1
And
and
it's
2.
quadrants what? 1, 2, 3, 4. Quadrant 1, quadrant 2?
Mhm.
That true, guys?
Mhm.
Woo! Matthew, at this point, I and you, we know angle A, the tangent is positive. So of the two quadrants where I should be, I'm in quadrant 1, which is the best quadrant ever. Cosine is also positive, 5/13. And it should be in quadrant 1 or quadrant 2, and I think cosine is negative in quadrant 2. So am I in quadrant 1 again?
Yeah.
So thank goodness both these angles are in quadrant 1. Now though, they want the cosine of the difference of those two angles. Now someone's had to give me a start. What are you going to reason here to do this, to make it work out for us? Susan, do me a favor real quickly. Find inverse tan, just out of curiosity. I don't know what it is myself. Find inverse tan of 4/3. What size is this angle?
53.13.
53
Yes.
point
13.
13. Lord, I wouldn't know that myself. Now, find this one. The inverse cosine 5/13.
It's 67.38.
I have no clue what's that. Okay. Wow. Hang on. Are we saying maybe those two with in the red that she gave me? If I take this one and subtract this one, oh my goodness. Nah, I don't want to get too carried away here. Is that like maybe 67 subtract 53?
Maybe like
Is that like
Or-
12 degrees difference, roughly, or not? Is it roughly 12 degrees difference? But is 12 on the unit circle to begin with? No, so there's more work to be done. Now, she gave me the approximations. Okay, now what are you gonna do? I know where angle A is supposed to be located. Oh, hang on. In the green here. Let me sketch it now, just in case. A is somewhere in quadrant 1. In fact, she says it's this. Over here, this one should be in quadrant, also quadrant 1.
Mhm.
We'll make it easy. And let's set something like that. And this is angle B. This is angle A. Ignacio. They want the difference of those two, and I'm not going to use what she gave me from a calculator, but that's what they want. They want the difference, A subtract B, and then express the cosine of that difference. What on earth can I do? No calculator. This is probably one of the toughest exercises. Okay, if you say draw a triangle, you want me to drop a perpendicular maybe? Okay, let's drop a perpendicular.
Yeah, because wouldn't we know?
Hang on.
Sorry.
I can do that. Angle A is in the corner. What do we know about angle A? Its tangent is 4/3. Now guys, one way to express the tangent is 4/3, what, y over x? So if I want to sketch, like Sophia's saying to do, Professor, I think you're gonna get a 5 here, Pythagorean theorem. Now, since I'm so accustomed to a unit circle, let's change it. Easily done. Divide everything by what? 5. And I'll come back to that later. I'm assuming, Sophia, you probably want me to do the same thing over here. Okay, hang on. Professor will drop a perpendicular. This is for angle B. Right right here. And what do we know about angle B? Its cosine is 5/13. The only thing I know about cosine, I think, from this class right now, cosine's definition is x. So could I place maybe 5/13 on the x?
Yeah.
And I know I want a 1 here for sure. Is that true? And then you use Pythagorean theorem. Does anyone know what c squared is equal to a squared plus b squared would give me with those numbers over here?
Minus 25. I don't know what 13 squared.
160.
169 is involved. Probably a 25 is involved.
So
And probably 169 subtract 25 is what, 144?
12 over 13.
So is it 12 over 13?
Yeah, it'd be 12 over 13. Need to remember.
You guys agree?
Yeah.
So at least it's represented. That's angle B. Now, they want cosine A minus B in the green. And thank goodness, that's why I went through this. We decided that it was it cosine A plus B or cosine A minus B?
It's cosine.
Is minus cosine A minus B, is it this formula?
Yeah.
Okay, so it's cosine A, go back to it, cosine A, cosine B, plus sine A, sine B. Wouldn't believe how few students could do this problem. Now, can I put in replacements? Yeah, cosine A, here's my A sketch. Cosine's merely 3/5, wasn't it? 3/5?
Yeah.
Down here. Cosine B,
5/13.
5/13 the x. Plus 4/5, go back to the A, sine.
12/13.
And over there, I think it's what, 12/13? And guys, the final answer is 15 plus 48, I think. Strange answer. What is 15 plus 48? 63? Is that 63 altogether? That's 15 over 65. Is this 48? Over 65? Is that 63? I did it quickly. Is it? Okay. May, if I saw you outside class, and sometimes I do, and some students just walk by me and don't say anything, because they know I'm gonna ask you a question. And May, I ask you to find this, you'll say, Professor, you're nuts. I have no idea. Look how much time it took us to go through this. Final answer, if we're correct, is 63 over 65. Sujit, would you please take this, subtract this. Yeah, take 53.13, subtract 67.38, and then take the cosine of that.
0.97.
Now, we have it as this. Now see what 63 divided by 65 is.
0.97.
Same thing. Marina was shaking her head, Professor, no way. That's a tough problem. That is a tough problem. If you just sit like a puzzle and you start putting the pieces together. Yeah,
So just to clarify, once we made the triangles, we had all the parts that we needed.
exactly.
Okay.
And Sophia suggested that. Now, some of my students love identities. You could have, I'm not going to do it completely here because we need a break here in 1 minute, okay? Can anyone tell me, hang on. Oh boy. I know 10 is 4/3. Is there an identity, if I did not want the triangles, is there an identity out there that somehow relates something here that I could use in an attempt to find something?
Y is equal to.
Well, no, an identity. Sine squared plus cosine squared is equal to 1.
You have to do that to find
Yeah.
sine, and then you could
Then you have
use,
to
just
another
substitute.
identity.
yeah, tan equals
Faster
sine
to
over
do.
cosine.
Oh, right here. And you're going to think it's sine over cosine.
Yeah.
Is that true? Could I have, this is what I was thinking of. one I did, that's overlooked sometimes.
Oh, and
Could
then
I
you-
use that?
Yeah, and then you can find the reciprocal.
There you go. And tan is 4/3, so that's 16/9, after you square it. What's that?
9/6.
25/9, that's what guys?
9/20.
9/3, or square root? Yes or no?
Yeah,
And therefore cosine should be the reciprocal,
3/5.
3/5.
and I think, did we somewhere get cosine to be 3/5 here?
That
So you
makes
could do it
sense.
through identities. And get the same answer. I see, it looks like, whoa, I need a break. Oh, that's one of the toughest. That is one of the toughest. If you see it on the exam, there'll probably be an extra credit. Probably more than likely will be an extra credit. One like that. Okay, guys, it's 6:14. So I'll see you in 10 minutes. Take a break.